Okay, so we've all seen what a single AI can do, right? But what happens when they actually start to form a team? The whole world of artificial intelligence is taking this massive leap forward, moving past these solo agents and into a future of really complex collaboration. And that's exactly what we're going to dig into today.
So here's our game plan. We're going to start with the big picture, this huge shift to multi-agent systems. Then we'll define exactly what they are and break down how they actually work together. After that, we'll look at some real-world examples, weigh the pros and the cons, and wrap up by looking at what this all means for the future of collective AI intelligence. All right, let's jump in.
A good way to think about it is like this. For the last few years, we've been watching these incredible solo AI performers. But now we're about to see the entire orchestra take the stage. And this isn't just some small upgrade, it's a totally fundamental shift in how we can use AI to solve problems that are just way too complex for any one player.
And that really brings us to the big question for today. We know a single AI can write code or analyze a ton of data, maybe even book you a flight. But what new powers get unlocked when they start to communicate, to coordinate, and act like a single intelligent unit?
This comparison really gets to the heart of it. A single agent is monolithic. It's powerful for sure, but it's a limited tool. It hits a wall when it tries to scale. But a multi-agent system, that's a whole different beast. It's modular, it's scalable, and most importantly, it's social. Each agent actually understands what the others are trying to do, and that lets them tackle problems that are just plain impossible to solve alone.
So let's move on and get a really clear definition for this whole team concept. What exactly do we mean when we're talking about a multi-agent system?
Okay, here's the formal definition. It's all about independent agents, right? Each one has its own little pocket of knowledge, and they coordinate to hit a collective goal. And the absolute key phrase here is without centralized control. There is no single boss calling all the shots. Now, to make that feel a little more real, just imagine a fleet of drones searching a disaster site. Each one is doing its own thing, flying its own path, making sure not to crash into the others. But they're also constantly sharing information about what they find. See, there's no central pilot for the whole fleet. They coordinate among themselves to cover the entire area way more efficiently and solve the problem much, much faster than a single drone ever could. That right there, that perfectly captures the core idea.
All right, so now that we know what they are, let's peek at the playbook. How do these agents actually coordinate with each other? What are the strategies and the structures that make this AI teamwork even possible?
So why go through all this trouble? Well, because you completely shatter the limits of a single AI. You get a system that can scale up massively and is way more robust. I mean, if one agent fails, the team just adapts and keeps going. Plus, you get specialization, where each agent becomes an expert in its own little area, making the whole system smarter and more efficient than any of its individual parts. So how do they do it? It really boils down to three main playbooks. First, you've got rule-based, which is basically a simple script. If this happens, then do that. Super predictable, but also super rigid. Then there's role-based, which is more like putting together a project team. You have a coder agent, a tester agent, a project manager agent. You get the idea. Each one has a specific job. And finally, the most advanced is model-based. This is where each agent is like a chess master, constantly thinking, predicting what the others are going to do, and adapting its strategy on the fly. It's unbelievably powerful, but also incredibly complex. And these teams can be organized in two main ways. First is centralized, which is a classic top-down approach. You have one brain controlling everything. It's simple, but it's also a single point of failure. If that one goes down, the whole thing collapses. The other way is decentralized, and that's our drone fleet again. There's no single boss. Agents just talk to their neighbors to coordinate. It's way more resilient, but as you can imagine, trying to orchestrate all that chaos is a huge technical challenge. And if we drill down even further, these agent teams can form some really fascinating structures. You can have a classic hierarchy, just like a corporate org chart. You can get something called holons, which is a really cool concept, where a team of agents starts acting as a single new super agent. Agents can also form temporary coalitions, kind of like a flash mob, to solve one specific problem and then just disband. Or they can be in permanent teams, where they're all tightly dependent on each other, kind of like a crew on a spaceship. Okay, that's enough theory. Let's see where these systems are actually making a difference out in the real world. Because this isn't just some blueprint for the future. It's already transforming major industries as we speak. And this is where things get really, really interesting. I mean, the applications are just incredible. In transportation, you have agents managing entire railroad networks, with each agent literally negotiating for track space in real time. In healthcare, they're simulating how an epidemic might spread, with each agent representing a person making decisions. They're running entire supply chains by having agents for factories, trucks, and stores all negotiate with each other to get products where they need to go. And in defense, they work as a team to simulate threats and hunt for cyber attacks on a network.
But of course, with a technology this powerful, we have to keep a balanced perspective. So let's take a look at both the enormous potential and the very real challenges that come with building these kinds of systems.
The promise here is just immense. These systems are flexible, they are ridiculously scalable, and they allow for deep specialization where every single agent is an expert. The bottom line here, the team's performance just blows a single agent right out of the water. It's not even close.
But, and this is a big but, the challenges are just as real. A single shared weakness in the underlying model could cause a catastrophic system-wide failure. And just teaching agents to negotiate effectively is a massive, massive challenge. Then you have this strange problem called emergent behavior, where the system as a whole starts doing things you never programmed it to do, and that can be both incredibly powerful and, frankly, a little dangerous.
So where is all of this going? Well, the ultimate goal, the holy grail, is something called collective intelligence, where the system itself becomes far more capable than the sum of its individual parts. This quote just nails it perfectly. As these agents collaborate, intelligent behaviors start to emerge that exceed what any single agent could ever dream of accomplishing on its own. It's not just addition, it's multiplication. Which leaves us with this final thought. As these AI teams get more and more sophisticated, what new forms of intelligence are we about to unlock? And, just as importantly, what new unforeseen challenges are going to come right along with them? That's really the question